Hello everyone, this is Srinidhi from Sri Venkateshwara College of Engineering from Department of ISC. Now I am talking of automation and IoT in introduction of mechanical engineering subject. Now let us know briefly about it. Introduction of automation in industry. Its introduction is definition types, pixel programmables and flexible automation, basic elements with block diagrams, advantages, introduction to IoT, definition and characteristics, physical design protocols, logical designs of IoT, functional blocks and communication model. Automation in industry definition. Automation is the creation and application of technologies to produce and deliver goods and services with minimal human itera- intervention. The implementation of automation technologies, technique and processes improve the efficiency, reliability and or speed of many tasks that were previously performed by humans. Automation is being used in the number of areas such as manufacturing, transport, defense facilities, operations, and lately information technology. And examples of automation in industry are production line automation, network automation, automated website testing, testing automation. These are the few examples of automation. Can you can see here. And advantages and limitations of automation. The advantages of automation are reduced human labor required, consistency in quality, favor risk of human error, improved health and safety, improved efficiency. The limitations of automation are be a costly initial investment, require some manual labor observation and programming. For example, failures could lead to temporary downtime in production. Unemployment may be a problem. Types of automation. Automation is are of three types. First one is flexible automation, second one is fixed automation, third is programmable automation. Now let us know briefly about the types of automation. Fixed automation. Fixed automation is the type of automation where the process of manufacturing stay fixed by the way it is configured, following a fixed sequence of automated progress. An example of this is flow production, where production were continuously being made. This is often also known as hard automation. Fixed automation can be expensive to set up initially due to the equipment required, but in return it provides high production rates. However, it is relatively inflexible when it comes to making charges to the product. This is relatively useful for many companies who were automatic automation to create food products of one type and variant. It allows them to effectively produce that item. You can see examples like Coca-Cola companies. The picture here, one is filling the Coca-Cola and other is capping up and transferring. And the advantages of fixed automation: high level of production, consistent quantity in production, low cost per unit produced. Disadvantages of fixed automation includes high initial cost, difficult to accommodate changes. Now let us know the other type, programmable automation. Programmable automation allows the production equipment and automation to be alerted to changing needs. This is done by controlling the automation through a program which can be coded in the certain ways for the automation to change the sequence of automation. It is used more commonly in low to medium level of production, often being most suitable for batch production. Programmable automation will often be used by factories who make different variant products. This allows them to make batches from a few dozen to potentially thousand at a time of one product. If the product needs changing, it simply needs to be reprogrammed. Advantages of programmable automation are flexible to change products if needed, suitable if batch production is required, and disadvantages are expensive, lower production level, often time consuming to change products. And the examples are computer numerical controlled, industrial robot, programmable logic controllers. And these are the examples of programmable automation. We can see there it's how the program is going on, and these are the examples. Now let us know about the flexible automation. Flexible automation, also known as soft automation, is similar to programmable automation, although a little more complicated. Essential flexible automation enables the production of different types of products without losing time when reprogramming. This type of automation tends to have a medium levels of production. There are essential differences in establishing flexible automation from programmable automation. A flexible automation system will be able to change the physical setup as well as programs with no loss in time and productivity. Altering the part programs is usually done by coding the programs offline on a computer and then transferring it to the automated system. Advantages of flexible automation are flexibility of products, no time lost with new changes to production. And disadvantages of fixed automation are high custom machinery, automation cost, high cost per unit. And example of fixed automation are, a simple example of flexible automation is a robot arm that can be programmed to insert screws, drill holes, and sand weld, insert rivets, and spray paint on objects in an assembly line. And these are the examples you can see here. Example of fixed automation. Now let us know about the IoT topic. The introduction of IoT. IoT stands for Internet of Things. It refers to the interconnectedness of physical devices such as appliances and vehicles that are embedded with software, sensors, and connectivity, which enables these objects to connect and exchange data. This technology allows for the collection and showing of data from a vast network of devices, creating opportunities for more efficient and automated system. The definition of IoT is the Internet of Things describes the network of physical object things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and system over the internet. And we can see the how the networking is going on in areas. We can see here with a picture. Characteristics of IoT. First, data sharing, self adapting intelligence, and dynamic changes, strong connectivity, scalable sensors, communication. Now let us know detailedly one another. Data sharing, since IoT is made up to interconnected devices, they share data with each other that can make each other more efficient and hence improve their performance. The characteristics of Internet of Things is evident in devices such as smart refrigerator, thermostats, and smart cars. Based on the collected data, they can even predict future events. Self-adapting, since these devices are smart due to the use of artificial intelligence and machine learning in them, they dynamically adapt to different conditions. For example, there are cameras that change their setting according to the lighting and shading intelligence. Another important characteristics of IoT too is their intelligence. Simple objects level interacting contribute to the collective intelligence of IoT networks. The collected data must be converted into information that can be utilized by the devices. This intelligence must be maintained and upgraded by this device as they keep on collecting information. The evolution of digital personal assistant like area certain and Siri is an example for the intelligence of electronic devices. Now, let us know the fourth one, dynamic changes. One of the important characteristics of Internet of Things in data collection from their environment. This is achieved through dynamic changes that occur in the environment around these devices. The state of these devices changes dynamically as well as the number of devices with people, place, and time. Strong connectivity, it is an important characteristics of IoT due to which anyone at the any time can collect from anywhere. This allows network connectivity and device interoperability. IoT can also connect manufacturing devices with identification, sensing, automation, and network capabilities. The connectivity allows these devices to be controlled remotely. Scalable IoT are capable of massive expansion with the ability to grow without affecting their performance by adding more hardware or software to the existing system. IoT devices can be scaled and more data can be handled without compressing their performance. And the seventh one is sensors. IoT works due to its sensors, which can precisely assess changes in the environment. This sensing information is the analog input from the physical world that provides a better understanding of complex world. This helps in accurate data collection, which not only makes the device more intelligent but also makes them more useful for the user. Communication, as internet of things are increasing in number, these devices are becoming more interconnected, hence they are most communicate with each other in order to work more efficiently and smoothly. Through could service, these devices are connected to the internet. This allows communication among devices. And the physical design of IoT. A physical design of IoT system refers to the individual node devices and their protocols that are utilized to create a functional IoT ecosystem. Each node device can perform tasks such as remote sensing, uh, acetylating, monitoring, etc. by relying on physically connected devices. It may also be capable to transmitting information through different types of wireless or wired connections. The things devices in IoT system are used for building connections, data processing, providing storage, providing interfaces, providing graphical interfaces. The devices generates data and the data is used to perform analysis and do operations for improving the system. For instance, a moisture sensor is used to obtain the moisture data for a location and the system analysis it to give an output. IoT protocols. These protocols are used to establish communication between a node device and a server over the internet. It helps to send commands to an IoT device and receive data from an IoT device over the internet. Different types of protocols are used that are present on the both the server and client side, and these protocols are managed by networks layers like applications transport network and the link layer. And we can see other IoT protocols conditions: application layer protocol and transport layer and network layer, link layer, and that's it. Now let us know briefly about those. Application layer protocol, it helps to send commands to an IoT device and receive data from an IoT device over the internet. Example is HTTP, hypertext transfer protocol. And transport layer, this layer is used to control the flow of data segments and handle error controlling also. This layer protocols provide end to end messages transfer capability. Example TCP, uh, transmission control protocol. Network layer, this layer is used to send datagrams from the source network to the destination network. We use IPv4 and IPv6 protocols as host definification that transfer data in packets. Example IPv4 and IPv6. And link layer protocols are used to send data over the networks physically layer. It also determines how the packets and coded and assigned by the devices. Example extent wi-fi etc. And the logic design of IoT. A logic design for an IoT system is the actual design of how its components, computers, sensors, and actuators should be arranged in complete a particular function. IoT logical design includes IoT functional blocks, IoT communication models, IoT APIs. And IoT functional blocks, IoT system includes several functional blocks such as device communication, security, service, and application. The functional blocks consist of devices that handle the communication between the server and the host, enable monitoring control functions, manage the data transfer, secure the IoT system and using automation, and provide the an interface for controlling the monitoring various. And IoT communication models, request response model, and publisher subscriber model. This communication model is based on the client IoT device making request and the server responding to the those requests upon receiving a request. And the publisher subscriber model, publishers, brokers, and consumers are involved in the communication model. Publishers are the source of data that send data to the topics. The broker manages the topics, and the consumers subscribers to the topics. Publishers and the consumers are unaware of each other upon receiving data for a topic. For the publisher, the broker forwards to the all subscribed consumer. As a result, broker are responsible for the received data from publishers and sending it to appropriate consumer. And we can see the both of them block diagram below the topic. This is the end. Thank you. Please like, share, and subscribe to my channel.